Alrighty, let's take a look at this question. So they're giving us a graph which indicates the sums, and the value of n down here tells you which position the term is in. So in other words, the first sum that is given, and S represents the sum, first sum is S1, so I wrote that over here. And then S2 would equal 4, wrote that here. S3 would equal 13, wrote that here. Now what that means, those aren't the actual terms. What they are the sum of the terms. So I've indicated that here. So S1, yes, this one in this case would equal the first term because the sum of the first term is simply the first term. But S2 would be the sum of both of the first terms. And if S2 is 4 and the first term was 1, that means the second term would have to be 3. Right? 4 minus 1 would equal 3. So see how the first two terms add up to 4? 1 plus 3, that equals 4, which is the sum of the first two terms. And then you do it the same way for S3. So S3 we know is 13. So all three of the first terms added together has to equal 13. So if you take S3 and then subtract the sum of the first two terms, S2, so 13 minus 4, you get the third term, which is 9. All right, now once you have the first three terms, you're away to the races, because now we can look at that and go, okay, looks like we're multiplying by 3 each time, so this is a geometric, I don't know if they indicated that anywhere, but we can tell from the terms now, it's a geometric sequence, and we know the first term is equal to 1, the common ratio would be 3 divided by 1, or 9 divided by 3, you divide the consecutive terms. So the common ratio would be 3. And we were given, this is kind of a typo here, but Tn equals 729. What is the value of n? I should have actually added that to my list over here. Okay, so if you take a look at your formula sheet to see which formula matches what we're given and what we're looking for, that would be this formula. Sorry, I doubled up on the A and the T1. So T1 times R to the n minus 1. Okay, equals Tn. And then we sub in what we have. So 729 equals first term, which is just 1, times common ratio of 3. And then we don't know n, so n minus 1 in the exponent. And then the 1 is just, we can divide that over, but it's just 1. So 729 still stays the same, equals 3 to the n minus 1. Now, if we can get the bases the same, figure out on the calculator 3 to some exponent what that would equal, that would be great. So you just guess and check on your calculator. And I do believe, if I am correct, that 3 to the exponent of, I want to say 6. Yeah, there we go. 3 to the 6 equals, so you replace 729 with 3 to the 6, still equals the same thing. And now that we have one power equals another power, 3 to the 6 equals 3 to the n minus 1, and the bases are both equal being 3, that would mean therefore that the exponents would have to equal 6 equals n minus 1, and now it's a simple equation, you just add 1 to both sides, and we get n is equal to 7 would be your answer. Alrighty, I hope that helped.